Hello everyone. In this video we're going to cover the cutoffs interpretation and how we determine our gross reservoir, and net pay flags. Let's get started. So last time we left off, we had just finished our water saturation interpretation and now we're going to move to our cutoffs interpretation. So we go to our module selection menu and we select cutoffs interpretation. So typically in a cutoffs analysis we try to define a gross reservoir, and net pay criteria, where gross reservoir is usually constrained by clay volume. Net reservoir is constrained by a combination of clay volume and porosity, and then net pay is a combination of clay volume, porosity, and water saturation. Now, of course, you can add as many or as few criteria as you want. You can use both calculated properties and or raw interpreted curves. So, if you have done your saturation, clay volume, and porosity interpretations, you can use those. But if not, you can always come in and do a very quick look cutoffs analysis using properties, for example, like the gamma ray curve, the resistivity, and the density value. So when it comes to setting these values, we use a basic expression language, and this is very similar to how we do filters. So for example, we can say at, which calls out our curve, and then vclay, so VWCL, and we're going to say less than or equal to 40% for this area, so that's 0.40. And so now that I've typed that into my zone default, I see that that's present in all my zones, and that's how we are defining it over here in this track. And so we can check this and say, okay, well, our Alston chalk is very low clay, and we see that that's all falling in gross reservoir, and most of our Eagleford in this area is falling below 40% V clay. So next we'd like to set our total porosity, or sorry, our net reservoir. And so we can come in here and we can say at, and then you can either set it with your effective or total porosity. So I'm going to use an effective porosity here, and I'm going to say greater than or equal to 0.04. And to combine criteria, we use 2 ampersand, so that's and. And then we could either type in, once again, at VWCL less than or equal to 0.40, or we can say at gross reservoir. And so this last one is probably a better choice, because by saying at gross reservoir, this means it meets the criteria of gross reservoir. So that means if we change this, this will now be updated as well, which is probably the desired behavior, that we only have to type in 1 number instead of 2. And then for net pay, we can come in here and say at SW less than or equal to, and in this case we're going to say 65%, and meets the criteria for net reservoir, so and at net underscore res. And so now we are flagging net pay, net reservoir, and gross reservoir. So we do have an additional option here called use minimum H, so that's setting a minimum thickness. And so what this is important for is if we zoom into some areas, we may see that we have some very thin pay markers. So let's set this to 0 for a second. If we set that to 0, we can see we have a lot of these little thin random stringers that we may not want. They're maybe too thin for us to worry about. So if we set that at, let's say, 2 feet, we clean up the log quite a bit. The other option we have here, which is one that is significantly less intuitive, is one called map partial zones. And what map partial zones tells the software is to map a zone even if there are some portions of the log that are null. So you could imagine that a situation where we only log part of a zone here. So for example, in this zone there is no top, so therefore it is a partial zone. And if you still wanted to create a summation, you would use the map partial zones option to sum over a zone where maybe you don't have a top defined or base defined, or where, you know, maybe there was a you know, portion of the log curve that may not have been digitized or originally logged. So that's what the map partial zones option is used for. And so that is how cutoffs analysis is done. You know, there is debate about, you know, whether or not we should use effective or total porosity, and, you know, whether or not the difference between net reservoir and net pay really still has meaning when we're working with organic shales. But we give you the full options here to customize your analysis however you would like. Hope you enjoyed this video, and for now, remember to save your work before moving along.